All right, so we'll just dive right in. First things first, this presentation was originally designed for our Blockchain University class / an investor pitch. So it was kind of geared towards a very non-technical audience, right? How many of you are sort of security, Bitcoin-ish professional, like you're deep in the weeds on this stuff? How many of you have a pretty decent familiarity with Bitcoin and how it works? How many of you have a decent familiarity with SSL certificates and how they work? Okay, so it's about half and half. You know, there's a variety of experience. So hopefully this will be fairly clear. Our vision, if an SSL security certificate is an I love you, with us you can take it back. Right? It's revocation at the click of a button, even for self-signed certificates. So you can think of this as revocation as a service. The team is Christopher Allen, he's the CTO, as we just got an introduction. Me, I'm CEO, and then Jared Holtz. Jared, where are you at? Over in the back there, he's our COO. The demo that we did, that you'll see a little later on, Jared basically hammered that out over the last day or so. It's just a little GUI that makes it so you guys don't have to stare at the command line and go, wait, what's happening there? While you're in the audience. Traction. So we've got interest from a few folks that we've spoken with so far. A medical payments company with almost $7 billion in revenue. An online media discovery service company, and a retailer that has both real-world offline stores as well as online sales of over $1 billion a year. The market opportunity. By making certificate revocation easy and functional, we help enterprise server security professionals communicate more clearly about the status of their systems. Right? So this is a big market. The SSL certificate market is over $4 billion a year, and it's growing at about 20% annually. And there's an untapped market for making self-signed certificates revocable. How many of you are familiar with self-signed certificates? How many of you have made a self-signed certificate? Okay. Almost everybody that was familiar with them had made one. Okay. The problem, there's currently no way to revoke a self-signed SSL security certificate. All right. Today, IT professionals can't use them to communicate with anybody else but their own systems because they can't take them back. So if I make a security certificate, there's no way for me to kind of undo that. And we'll get into why that is a little bit later. That deals with sort of the architecture of the industry. Current solutions don't use those self-signed certificates for talking to anybody but you. Right? So within your system, you can use these, but when you're trying to talk to other people, no. Problem one, it makes secure communication with others dependent on connecting to the certificate authority. So some company like VeriSign or GoDaddy, right? And that there's a single point of failure there during a compromise. Let's say you've created a security certificate, VeriSign created a security certificate for you. Something went wrong. Somebody hacked your system, you realized there was a bug, something else. There was a compromise of some sort. You say, hey, I need to revoke this thing. Great, it's been revoked. That revocation is not reliably communicated to users all the time. We'll go into some of the ways that fails. That's the second one. The third one is it's expensive, right? When you pay for a certificate authority, how many of you have paid for these things? How much have you paid? What's the most you've spent on a certificate?
$650.
$650? Great. What's the cheapest? Free, right? And what's the hook on the free ones?
Pay to revoke it.
You pay to revoke it. Okay. RevokeSSL lets enterprise IT staff create a revocable certificate in minutes, regardless of whether that certificate is self-signed or issued by a CA. They can revoke with one click using our application, or remotely, independently of us, via a Bitcoin transaction. Others can check to see if the certificate has been revoked quickly, privately, and with no centralized point of failure. I'll be very blunt. A lot of you are really technically savvy. We are not doing something super technically complicated, right? We're doing something very simple that happens to use the blockchain to solve a problem. This is just a little under the hood intro. Security certificates, it's basically you've got a bunch of fields, right? So when you fill one of these things out, what country are you in? What state are you in? What city are you in? What's the name of your organization? What's the name of your organizational unit? What's your organizational unit?
Depends on the application.
Right. How many of you who do SSL certificates, how many of you routinely leave organizational unit blank? Anybody? Some people. How many of you find it to be a really critical part of the certificate? Anyone? Okay. So that's something we're banking on. Basically, we've sat here and gone, hey, that part, organizational unit name, is this field that we could sort of hack and use in a different way. The big picture is that we want to create a relationship between a new Bitcoin address and a new SSL security certificate. The steps. You create a Bitcoin address. We call it a claim address. You check that there are no prior transactions. So you create a new address. It's never been used before. You make sure it's never been used before. Great. It's sitting there. Nothing has gone into it. It's just sitting there. You apply for an SSL certificate. You could self-sign. You could create this yourself, or you could go to VeriSign or Thout or somebody else. And when you're applying for that certificate, in this organizational unit name field, you put the Bitcoin address into that field. We actually prepend BTC underscore or something like that. We assume that we're going to use multiple blockchains in the future. We want A, to be able to distinguish between, the IT department in that field and, oh, this is a reference to a revocation claim. So we want that. But B, we also want an indicator of what kind of field you might, what chain you're looking up an address on, right? Are you looking this up on Ethereum? Are you looking this up in Bitcoin, et cetera? You then generate the certificate, again, with that Bitcoin address in the organizational unit field. You hash I wrote hash the certificate, but it's really you hash the signature of the certificate. You then create a second Bitcoin address, and the reason we're doing this is that a lot of the existing applications for paying things don't allow you to do an op return. It's not like built in, so we're making sure, hey, we're creating our own. You create a second Bitcoin address and you put some Bitcoin into that, right, through whatever mechanism you want to use. Then you create a transaction that transfers some Bitcoin from that feeder address over to the claim address. And with that transaction, you include the signature hash in an op return. An op return is basically like a comment on that transaction. The certificate now includes a reference to the claim address in its organizational unit field. And the claim address on the blockchain now includes a reference to the certificate, the signature hash that's included in the op return in the funding transaction. Revocation steps. So that's it. It's done. It's created. It's on there. You can revoke the certificate simply by spending any of the Bitcoin in the claim address. You can include a comment in the op return of that transaction, clarifying that this spend is intended as a revocation of that certificate. And you can reference the signature hash. Do you need that second part? No. But it makes it clearer to anybody that's checking this that you actually intended to revoke this thing. That when you spent that money, you meant this as a, hey, I no longer stand behind the claim that I had previously made. Status checking. Any user can check the status of the certificate, i.e. whether or not it has been revoked. And I want to point out, we grappled with words here for a while. We were using validate, and you'll actually see in our demo the words validate, but they can check whether it's valid, but that's not really it, right? They're just checking whether or not it's been revoked, because there may be other reasons why this certificate's no longer valid. It could have expired. There could be something else. So you're checking the status by checking for transaction outputs to see if there has ever been money going away from that address. You can do that using any blockchain explorer. We're creating a checker that automates this lookup process, but it can be done independently by the user as well. If there are no transaction outputs for that address, the claim stands, right? If there have been any transaction outputs, the claim's been revoked. While it's not necessary, if you have that comment in an op return, you can communicate that, hey, I meant to revoke that certificate.
And why?
Sure, and you can put the reason. Like, we got hacked, or heartbleed, or whatever the reason may be. Demo. So this is just a little GUI demo. Jared, do you, am I supposed to hit a specific thing here to make this full screen? Is there a icon that I can hit? Or no? That's it. Fine. Okay.
Just make it larger. There's a scroll.
How's that?
Scroll.
All right. So basically, we've got three things you can do here. You can create, you can revoke, you can validate. So create, you click create new. And with that, it's generated a new Bitcoin address, right? It gives us not the address, but this thing to copy, and that's the address with that BTC underscore prepended. You click that to copy it, and then you're going to generate, when you're doing your SSL, when you're asking for the new certificate, you're just going to paste that thing into the field. If it's your self-signed certificate, great, you're doing this on your own computer. If you're dealing with VeriSign, you're entering this stuff through their website. You complete that certificate application, and once that certificate is created, you've got a file. You drag and drop that file here, and we're going to hash the signature, right? We've got that signature hashed. We take some money. This is one way that this could work. We're hoping that we get to take money. This is one way this could work. And there's some payment things going on. You do credit card or you pay for Bitcoin, whatever. And then after that money has been received, we go, great, your revocable claim has been created. What happened in the background? We created the feeder account. We then created the transaction. We put that op return in with the signature hash. We fed that stuff all. Right? So all that stuff happens behind the scenes, but all the person has to do is click, pay, good. Right? Aside from the click, copy, paste, pay, good. You want to revoke the thing? Or, well, let's check it first. Is it valid? Which claim address would you like to check? For this, we just pasted in already. Hey, it's not been revoked yet, right? So there have been no transactions that left that Bitcoin address. To revoke, we've got a little safety switch. Some friends of mine, Mark Stiegler, Alan Karp, they did a paper a few years ago called Are You Sure? Yes, Oops. And are You Sure? Yes, Oops had to do with the process by which it was like you click something and it's like, are you sure you want to do this? And then you say yes, and you're like, oh shoot. And that split second later you realize I really should not have done that. And the thing that they proposed was you do it the way that they do it in the military, basically, right? You've got the safety, you turn the safety, take the safety off, so you make a decision that yes, I want to arm this thing, then you hit the button. It makes it so it's a conscious decision as opposed to something that you just run right by. So, oops. Safety switch, you click the button, done, revoked, right? When you go to validate now, your certificate, that certificate's been revoked. And anybody who goes to check that Bitcoin, uses a blockchain explorer to go check that address, can see, yeah, there was money transferred away, it's been revoked. I'm going to go back to the slideshow. So the initial focus is revocation as a service for self-signed certificates. It doesn't need support from browsers, certificate authorities, standards bodies, etc. Right? It can be deployed today. And it can even work for offline systems through a phone-based RevokeSSL. So this would be like your system, the servers that you're working on, don't communicate with the internet. That's okay. You can do the SSL certificate generation there. And you can either type in the hash of the certificate, or if there's some way for you to get a QR, you can snap a photo, and through your phone you can do the whole process of adding this to the Bitcoin blockchain, etc. Revocation works the same way, right? Once it's there, you can revoke simply from a push of a button. Of course, checking would also have to happen through a phone. There. Revenue model, we don't know, to be totally honest. But at the moment, we create some application that makes it really easy for people to roll their own revocable claims. We do monthly subscription for a number of claim addresses, so it's $10 a month and you get 50 claims, or 50 revocable claims a month, or it's a charge per claim. I have no idea. We're going to figure this out as we go. Future revenue models, and this actually gets a little more interesting. So revocable server to server, basically revocable SSH keys. solves a different problem for the same market. We're playing around with this right now, and every time I talk to people in this world, they go, oh, the self-sign thing, that's interesting, and the SSH thing is like really interesting, right? So it may be that that's actually what we end up going and doing, but it's the same principle just applied to a different problem. We may end up charging per certificate for CA certificates. Of course, that is going to end up requiring browser adoption, and we'll go into why that is in a minute. DV, OV, EV, for those of you who are not familiar, there are different types of security certificates, and they essentially have to do with what is being validated. So DV stands for domain validation. In other words, yes, this is the website that you think you're talking to. OV stands for organization validation. Yes, this is the organization. There's actually a legal entity behind this with that name, etc. EV, as I understand it, is kind of like a way to boost the profit margins of the certificate authorities. If it was recommended, we'd pay $150 for revocation services on a $500 EV certificate. So this is something that one of the people we talked to told us. And of course, our ears perked up. But that was if it's recommended, right? So that means there has to be some standards bodies, folks. There has to be some widespread support within the community about, yeah, this is the good way to do it. This is the smart way to do it. We may try to partner with others in the industry to help this spread. And my take on that is, how do you make this benefit everybody involved so that they go, yeah, this is the right thing? If it is the right answer, that's wonderful. But unless they aren't getting screwed by you succeeding, it might be a hard road. Long story short, in terms of how we're going to reach out to folks, meetups and conferences and all that sort of stuff. I don't know that you guys are super interested in all of that. Exit strategy, we don't know. There's people who might be able to buy us. Some of them are certificate authorities. Microsoft is the 500-pound gorilla in that space. They basically, if they say, you need to do this, all the certificate authority goes, yep, we'll do that. So there's some potential there. But it's early days. We have no real idea of how this is all going to pan out. Competition. Currently, revocation is bundled with the issuance of a certificate from a CA. It works poorly, and the reason it works poorly is because the communication is unreliable.
And I can talk more about that.
Yeah, he can dive into that. And it's a cost center for those CAs. So certain forms of revocation are like, hey, ping us and we'll let you know if it's still good. Well, if you have a domain, a website that has a really high number of users doing lots of things, that's a lot of cost for that certificate authority just to be servicing all of those. They've come up with other things, OCSP stapling, that try to address some of these, but each of them have some issues. We are an independent revocation service provider. The advantage is revocation that can be checked reliably and fast. It works with self-signed certificates. Privacy concerns are addressed, so there's nobody happening to be watching all of your users as they're asking for, is this thing still good? Is this thing still good? And there's cost savings for the issuing certificate authority as well. We're looking for investment. We're looking for 6 months of funding to demonstrate product market fit, and that looks like some minimum viable product and some paying customers. We're seeking a $200,000 convertible note over the next month or two, and 60% of that goes to the three of us on a living wage, one enterprise developer, and then sales and marketing, which basically means we're going to go to some conferences and talk to a bunch of people. Contact, if any of you are interested in working on this stuff in any way, shape, or form. We really are looking for partners and other people to play with. So if any of you go, that's cool, I'm curious about that, whether as a developer or a front-end person or something else, in sales, whatever, contact Chris.
So can pull up the browser. So my GitHub is Christopher A. And are we on the net?
Should be.
There we go. It's being slow. So this is the hack. It is a hack. It's not very efficient. But the fact that we did it in very little time, and we had dozens of choices. We could use blockchains API. We could use, what's your favorite Bitcoin API these days? Just What's yours? Which one do you use? So anyhow, there are lots of them, which is great from a security point of view. It means that it's it is heterogeneous. We have lots of different choices. You can basically have a phone class device that can have the complete blockchain on it. I've seen it. There are little $100 boxes now that will put an entire copy of the blockchain on the device. You can interrogate that locally. You can use multiple different channels out. You can have that have a not a Wi-Fi, but an LTE connection out through cellular to get its updates of the chain, which means that revocations on the Bitcoin blockchain are distributed worldwide in 10 minutes. So there may be applications of this where people need revocation fast. That's not the problem. The problem is getting that it's revoked at all. So the original way with SSL was something called a certificate revocation list, which is basically this long list that a CA will provide on a URL that basically says, here are all the certificates that have been revoked. Well, Mozilla, 3 years ago, maybe 4 years ago now, did a study of this, and over half of the endpoints of certificates did not respond. And the ones that did respond, it was over 200 megabytes of bad certificates. That means every browser could potentially have and search for bad certificates in this 200 megabytes. When Heartbleed happened, a whole bunch of CAs were caught with their pants down, in the sense that people revoked and it didn't work. People would try to revoke. It didn't work because people were pounding. I mean, we're not talking about that many developers, but there were enough developers trying to revoke their certificates, they weren't getting revoked. In addition, when people were verifying those certificates, whether or not it was through the old certificate revocation lists or some of the newer protocols like OCSP, again, a lot of people didn't respond properly. There's also privacy concerns with OCSP. Basically, your CA can know all of your customers, because every one of them is communicating with the CA to find out that that certificate is valid. There are CAs out there who are selling this information. Okay? So the whole thing of having revocation tightly tied with the CA, I think is a problem, and that's where the inspiration for this came from. Does this have problems? Yes. You're welcome to look at the issues. I left this one in here. They're basically saying it's proof. It's signed with time. Anybody can create them. Man in the middle is possible with self-signed. Don't use a self-signed certificate then. Use a regular certificate. Does it, making a transaction with this certificate signature does not prevent anyone from doing the same? Well, the issue there is you're the one who issued the certificate, not the CA, and to a certain extent, you got issued. You're the one who requested the certificate. They issued it. It's up to you to revoke. They can revoke also. There may be multiple channels. Maybe we have 20 different ways to revoke things. We're just providing another channel that's fast, that's efficient, that's just a few lines of code that can be done in JavaScript, Python, C, whatever you want it to be. Sort of on the long term of this actually came out of some research that I was doing on some technologies that died. How many people here know what spooky or sudsy is? How many people here know what attribute certificates are? A couple people. How many people know what a pet name is? Okay. A lot of people are familiar with Web of Trust in the PGP sense. Similar kinds of problems happened in the Web of Trust. Okay, now I have a bad certificate. How do I communicate that my signing of your certificate that somebody spoofed me, and I discovered later that someone spoofed. So a lot of these technologies died on the vine because of the lack of the viability, the ease to revoke. And I'm basically, let's make revocation really, really easy, because that allows us to do these more advanced, different kinds of approaches possible that weren't possible before. Let's make certificates shorter, shorter in length, et cetera. What if?
We put together a little story. How many of you feel like, oh, I totally know how certificate authorities and SSL security certificates work? Okay. How many of you not so much? Okay. I was going to do, basically we created a little analogy, and Jared and I hammered on this yesterday and today. So I'll try to walk through it. Before I do that, Blockchain University, where we basically got to take the time to hack on this stuff over a number of weekends, is offering you guys, and only you guys, $250 off. When do they start the next class? Is it?
It's July something.
Okay. I thought it was sooner than that. Anyway, bit.ly.250 off BCU. Robert, the founder, asked me to pass that along to you guys. So that's just for the folks here at SF Bitcoin Meetup. And if one of you is like, I didn't write it down, ask somebody else or me. So first we're going to talk about what SSL is all about.
Maybe we should go to Q&A.
Should we go to Q&A first?
So we can talk about this, and I'd be glad to share with people, some details of SSL, for instance, why it's called TLS, et cetera, and I can answer that in the Q&A as it emerges. But what is it that excited you about this possibility? What was the opportunity here that you saw that made you want to come up here?
What excites me is the thing you're not talking about, which is the possibility of actually being able to register your self-signed certificate with something like, with a capability like Namecoin.
Mm-hmm.
And then the other thing that you haven't answered for me, and maybe this will do it, is how my browser is going to know that it was revoked when I upload that.
So clearly it's easiest among server vendors because the code is available for them to be able to put in an additional check. We're not replacing the certification check. We're just basically after the code that is doing the certification check now, we're adding one more step. So it's pretty easy to put into existing code. But if you don't have the code, you can't do this. This is very easily doable with a Chrome plugin. So basically, you have the Chrome plugin, and every time it recognizes that there's a new HTTPS certificate, it looks at the certificate, the browser is already reporting to it that it's valid, you just do an additional check. Just look for the organizational unit field right now. Long term, there are other certificate fields that are possible. There are other different ways we can insert this in things. But I have to admit, how many people here work for a CA? I'm ambivalent about CAs.
It's being recorded.
I know. I'm being careful. I'm ambivalent about CAs. Okay. X.509 existed before SSL. X.509 was a failed part of a standard called X.500 that was invented in the 70s by an international organization that spent, by today's money, billions of dollars and failed. But X.509, succeeded, moved on, and to a certain extent, I felt as the creators of SSL, we were forced to use X.509. We would have much preferred something that was more like a web of trust model or some other kind of certification approach. If we had not been forced into doing X.509, X.509 would be dead today. Because we're basically it. PEM, privacy enhanced mail, which uses X.509, nobody does that. Trying to think what else uses X.509 that isn't. Yeah. So what are the problems with X.509? Besides the technical side of the standard, the business model is about friction. the CAs of the 90s were saying, oh, we're providing security, we're going to make sure that your identity is who you say you are. The reality was that the security was that they were putting friction on the system. That by charging $100 or $200 and making you go through all the rigmarole, they were just slowing attackers down. Why do we have to pay them to slow things down? There are lots of other ways to slow things down. There are lots of other ways to cause problems or whatever to make it a viable system. As he said, extended validation. How many people have an EV certificate? Nobody here. Basically, they're supposedly checking to see whether or not you're meeting the standards of, your industry for your use. I don't know anybody who's actually been inspected. I did security reviews for VeriSign for a short period of time. Over half of our security reviews failed of servers. Over half. What was VeriSign's response to this? VeriSign's response was, oh, we're going to have people self-certify because this is slowing down our sales process and we want to go public. Okay? This is what we need to figure out how to do and we need to figure out solutions for. I saw a question there a minute ago. What was
back here?
I have some more questions. What if instead of your certificate being compromised, which is what causes you to want to revoke your certificate, your Bitcoin address is compromised?
Well, that's the thing is that your Bitcoin address can only have transactions added to it. So any kind of out is...
So if they steal your claim address money, it achieves the goal of revocation. Okay, that was the easy question. The hard question, okay, you say that the existing certificate of revocation doesn't work because of the potential traffic, like Heartbleed came along. All of a sudden, people needed to get 200 megabytes worth of revocation lists. If everyone adopts this, won't there be gigabytes of valid certificate transactions on the blockchain instead of at the CAs?
Well, there's a couple of different things here. First off, this is a massively replicated database, and we're doing basically 40 bytes per certificate.
But still, there's like
correct.
Millions in the...
I understand.
Yeah.
There are also lots of other side chains and other different types of places that you can put this information. There's lots of different work on using blockchain technologies for distributing information redundantly. IPFS is one of my favorites that I'm playing around with right now. And it's the whole system is designed to be redundant to start off with because they're all trying to prevent the double spend problem. So we're just taking advantage of the fact that they're trying to service these transactions as fast as possible so that money isn't double spent to basically do the same for us.
So you're still hoping that there'll be some blockchain that tens of gigabytes worth of valid certificate things will be able to live?
Many blockchains,
Okay.
right? And that's part of the reason why we're pre-pending in the organizational unit field, because we don't want to assume that it's going to be Bitcoin, right?
So
we want this thing to be able to shift as the landscape that we're operating in changes.
There's also ways that we can still use the blockchain, and so I really feel like there needs to be something under the blockchain that allows us to have distributed hash tables so that we can basically have, everybody who wants a time signature goes into it, for 10 minutes, goes into a distributed hash table. The hash table, goes up, and then basically just the root of that hash table is what it's put in Bitcoin. Right now, there are people that are doing this in a non-decentralized way. They're creating their own hash tree tables and services and things of that nature. I would really like to see some kind of consensus-based mechanism for these kinds of services as well.
Saying that the whole certificate is not being stored in the blockchain either. It's just a hash table, so it's going to be a lot smaller than
It adds up.
It's transactions, but those transactions are getting paid for, right?
Yeah, there is a service fee.
We're including transaction fees so that we get processed. And
So right now, Bitcoin, it's around 8 cents to have a transaction that is reliably processed by the miners within 10 minutes. So if you have less, you may get picked up, but it might take a day for you to be fit in the puzzle of some miner somewhere to do that. Right now, I don't believe miners are optimizing. If you put $10 on there, they're not necessarily optimizing, but there are ways to do there. There's also a lot of other potential things you can do. So Bitcoin has a concept of multi-sig transactions. So what I could do is say, I trust you, we've been working together for a while. I'm going to give you one of my multi-sigs, but not sufficient to spend the money. But I'm going to give you one of my other multi-sigs, okay? All it requires is the two of them to collaborate to basically spend that money. So I can basically make a bond, in effect. I could put $1,000 on there and saying, I really believe in this claim that I've made. I can revoke it at any time because I have the real private key. They can reconstruct the private key if they collaborate. And if for some reason they feel like I'm violating the rules of our system, they can basically, give themselves $500 each, or give it to a charity like EFF or whatever. So there's some bonding things that are possible here. A lot of possibilities.
So I think my question is naive, or maybe it reflects my lack of understanding of sort of overall this thing. I think it's cool. It looks very cool what you did. I think it is actually cool. The global PKI seems seriously broken. I think there's a lot of people who could, make a stronger case for that than I do. If the problem is, like, how does my server trust his server? Did you evaluate opportunities to do that directly with, blockchain code and just forget the whole PKI SSL stuff?
You certainly can. So what's really required for that is a shared secret between the two of you. Okay. So one of my favorite shared secret techniques is the 25519 curve. Look it up. 25519. It's not a very common search term. It's 32 bytes. It's 64 bytes when signed. You can do a lot of things with this particular curve, and one of which is that you can create a Diffie-Hellman purely by having the two public keys of the two parties. You're actually eliminating a whole lot of the steps that you have to do in a traditional Diffie-Hellman exchange. So yeah, you could publish your public your public component of that curve in the blockchain with some identity, and then somebody, but they still have this problem of, is that really you? There's some point in the classic, web of trust of, hey John, what's the hash of yours? Okay, this is the hash of mine, and then we sign each other's key in web of trust. The same thing happens in all of these. We're trying to prevent that man in the middle. And Diffie-Hellman is, guaranteed to be, confidential between the two parties, but that doesn't necessarily mean that once it leaves that confidentiality, they're not spelling it to somebody else. So you have to have
leveraging the existing CAs for that initial identification registration stuff, and then you make the valid, not to use the word validation, but the checking of that certificate that's used to ramp up the.
And it doesn't have to be one of these big CAs. I mean, like I said, you who has a $5,000 a month web service business of some kind may have a very different requirement than a $1 billion company that's public. Okay, they may not even trust VeriSign. They might not trust any of these. They may decide they want to go with 3 different companies. Right now, they can't. They choose their CA. If that's the CA they use, they're stuck with it. I would like to see choice in there. In fact, I can sign it, and VeriSign can sign it, and somebody else can sign it, and then you can decide as the user of this, okay, there's sufficient things here. There's also an additional property here, which we didn't talk too much about, which is something called proof of existence. So what happens is not, when you've created that first transaction, way back when, that's in the blockchain that's accurate within 10 minutes of time. So you can now validate that, yes, this certificate was valid in the past. If you look at what people are doing with certificate pinning, which is a particular technique that's kind of a hack in and of itself, to especially with cell phones. Right now, if trying to think who's the one I was just, Instagram. I was talking with one of the people at Instagram. So they basically, with the app, are pinning hard on part of the certificate chain into the code of the app, because they can't rely on revocation. They're just basically trusting, as long as this certificate doesn't change, go ahead and continue to trust. Well, if that becomes invalid, the only way that they have to change this is to update their entire app. Well, when they update their app, only 80% of their customers update. So that means 20% of their customers have the old certificate and are now, in effect, have a denial of service against their use of Instagram, and they can't afford that type of thing. So, there's interesting problems with pinning. This, in a way, is pinning as well. We're pinning in the past that this was valid on June 1st, 2015, and I can go, 10 years from now, I can go back and look and go, yeah, it was valid from June 1st until I revoked it on June 25th. Or it's still valid today, and people have been using it for 5 years without any problems. Gosh, 5 years is a long time. I might be willing to add that to my list of reasons why I might trust this particular server.
I'll make a separate comment, which is one of the things that most attracted me to Christopher. Christopher came to a meetup that I had started a couple of years ago called Build the Collaborative Internet, and there are a few of the folks from that group in this room now. And one of the things that I was most interested in was his understanding not only of the mechanisms of trust that we use to do online security, but how human trust works. And his talk earlier about heterogeneity as a benefit, well, it's at one level, the way I look at this is contexts vary, and the point that you just made about the $5,000 versus $1 billion, you have different needs. We all have different levels of which we care about getting screwed over, right? Do I care that somebody I didn't plan on seeing my Yelp review sees it? Well, not really, Do I care that somebody who I didn't plan on taking control of my bank account takes control of my bank account? Yeah, kind of a lot, right? Especially if there wasn't some sort of insurance or the bank making me whole process backing that. As a result, because there is that variety, if you're able to give individuals choice over how they're going to go about protecting themselves, you don't have to figure out the one size fits all. Because there is no one size that fits all in security, right? You're able to enable them to go, you know what, in this situation, I'm okay with only that much protection. I'm okay with investing only this much in protecting myself. In this other situation, I really need a lot more. And I do believe that being able, one way that you can make yourself immune or securitize something is by being able to revoke. So sometimes I'm unwilling to give out my email address to certain people. Why?
Because they'll send you email.
Because they'll send me email. And they might send my email address to other people who will send me email, right? And I don't like getting all of that spam. My inability to revoke my email address, to revoke their ability to send me email, is what makes me unable to publish my email in the first place. And so I've been talking with Christopher for the last 8 months because I've been really excited about wanting to do revocable contact information. Right? That's what I'm working on sort of separately from this stuff. But that's the basic concept. If you can't take something back, then you are less free to give it away in the first place. If you can't withdraw something, you can't communicate in the first place. So I'm a political theorist, that kind of was in the introduction. And I think a lot about privacy as sort of the if you have a yin-yang, if you have sort of a pair of things that are tied together, privacy and freedom of speech are closely coupled. Because freedom of speech deals with the ability to communicate, right? To get your message out. Privacy isn't about shame. Privacy is really about some control. Privacy is about control over your own body initially. Slavery, the reason we have final slavery is because somebody else is taking control over how your body's going to get used. Same with rape, right? Information privacy deals with really control over distribution of information. My expectation was that I was alone in the shower and nobody was going to hear me singing or see me naked. If that shows up on TV, that's kind of sucks. And over time, if my ability to judge what the context is, I thought I was alone, it turns out I was public. If I routinely am unable to assess that what the context is, I'm not able to exercise control over how broadly that information gets distributed, I stop being able to communicate. Right? So my belief is the ability to constrain how far and how broadly and to whom a message gets communicated frees us to communicate. So that's why I'm interested in the revocation stuff. Okay. Other questions? Yeah.
Where are the private keys for the Bitcoin address?
So it depends on, if you use our service, you may have us be one of the shares to be able to, you may elect to have us be able to be a custodian, just like any other Bitcoin thing there, or you can do it yourself. We also support paper. So you can literally, when you do this, do it all in JavaScript, print it. You now have a paper wallet, and then we'll have an iPhone app or an Android app that allows you to spend the money off of that paper wallet. So it's, what the final best technique and everything depends on, your security requirements. I happen to like the paper wallet thing. He's not as big a fan of it.
No, I think it's useful. I think it's nicest because it demonstrates the freedom.
Yeah.
Right? That if you decide, hey, I don't trust anybody else, and I don't even trust my computer, your point, his argument for this is you print it and you put it in the safety deposit box, right? If you want to go revoke it later, you got to be able to gain access to that safety deposit box, take it out, snap a pic of it.
I mean, how many people have played with paper wallets? They're kind of fun. I mean, sure, there's a risk associated with them that somebody gets a hold of your paper wallet, or you lose it, or someplace there's 250,000 bitcoins mined by Satoshi, and who knows where that where those are. But it demonstrates that you can do some interesting things with just QR codes and an iPhone app. So.
Yeah, I'm wondering just how you're envisioning these browsers and other devices querying for the revocation. So you say that they'll basically be querying for an outgoing transaction from that address.
Correct.
So I guess you end up using basically any of the popular APIs. I think.
I mean, I would actually recommend you use multiples.
I think it would be a little difficult though for people to just use their own trusted nodes, because I think even if you have a fully indexed Bitcoin core node, you're only going to be able to look at transaction hashes. I don't think you can arbitrarily look for all of the transactions outgoing.
You don't need to. All you need to know is whether or not they're, because you don't need to look up the transaction. I admit, looking up old transactions can be hard, and so I think there's a version of Bitcore that makes a 200, 300 gigabyte sized version of the chain so that you can search the whole thing. But no, what you're really looking at, all you're really doing is looking at the Bitcoin address. And those, by design, are meant to be very quick lookup to see, has anything been spent on this address? It's very, very quick. Because that's what prevents double spending.
You probably end up using, one of the additional layers on top of Bitcoin core that gives you the additional indexing to look it up by address.
I think Bitcoin does that for addresses, but
By transaction ID instead of address.
Okay. But in any case, I mean, it's not again, so who would want to do this? Okay, so let's take the $1 billion beverage company, okay? They have this situation where they have a bunch of franchises all over the United States that have cash registers and services and all this kind of stuff, and theoretically, their brand is at risk to these independent franchises that are out there. They want the ability to basically, if there's an attack against them or against the franchises, to be able to revoke the franchise certificates or the certificate or their own certificates. It's no big deal to have a little, I mean, I could do it with an old iPhone 5 that's laying around, and with a USB connection to the server, and it has a full copy of the blockchain. It's doable. And have a completely independent way that's completely independent. The attacker would have to be, putting a firewall, some kind of attack against the entire, LTE spectrum.
Yeah, it definitely seems worthwhile for enterprises. I guess if you then explore the option of perhaps sort of partnering with or layering on top of some of these, like the BitSeed device or the other hardware devices, and provide those APIs.
Yeah.
Great.
So who wants to do this? So some of the Bitcoin core folks, the people that are offering different services, what concerns do you have with this? Are you concerned about how many transactions are going to go on the internet? I mean, on the blockchain?
Let's have the block size debate right here, right now.
So, it is interesting, the queries, it's a use case that I'm not that familiar with, where you're actually doing just a lot of read-only queries to the blockchain. I don't know how well the system would handle that.
If it's for addresses, if it's for payment addresses, it's optimized for that. Because a payment address is not your public key. It is a hash of your public key, and it's designed to be very quick.
How far could we be from a world without CAs?
I'm hoping. There's two questions with the.
We might need to partner with them.
Yeah. Well, that's exactly it. I think there's a transition. Okay, I'll be blunt. And if they don't get in on the transition in some type of fashion, they will be disintermediated.
Yeah.
So it's in their interest to find ways to continue to offer the services that they offer. For those that need it, but we have a lot more security things to work on. So I saw a questioning eyebrow.
I work with OK Turtles, and I think blockchain-based disintermediation with CA is much closer around the corner than a lot of people think. It's inevitable. It's a question of when, not if.
I to a certain extent agree with you, and I like what DNS Chain is doing, but I've also talked deeply with the kinds of problems that the open DNS is having. Okay, the reason why people are paying them tens of thousands of dollars a month for their DNS services. So there's a bunch of different things that are on the DNS, how DNS is constructed, how it's how it's distributed, etc. That is that the DNS chain stuff doesn't address in a scaling type fashion that OpenDNS does. So it's going to be a long road, and who has the expertise? The expertise is at OpenDNS. So we have to find ways for people who have the knowledge of the challenges of scaling, the corporate challenges, the different oddball use cases, the different kinds of attacks and things of that nature, to say, yes, here is a transition strategy to a blockchain-based DNS, and it has to, here are the 5 things that it has to do for us to even begin to deploy it. I don't think DNS Chain's at that point yet.
This just popped into my head, but I'm envisioning when a government revolution happens, when a civil war happens in a country, and they throw out the old regime and they kill off all the people who were in charge. how well does that usually work out? Right? Because all the talent that knew how everything worked, it's kind of gone. So there's a vacuum. If the Bitcoin radicals aren't able to include those folks in some way, like I know there's this passion and drive for, we're going to replace it all. Like I'm trying to build things adjacent to existing systems, but I'm also trying to find ways to co-opt all of those actors in. It doesn't have to be the enterprise, but maybe the people that are in the enterprise, right? How can you co-opt them and get them in so that this works for them and their knowledge doesn't get lost along the way, you know? And some of that knowledge is terrible knowledge, right? It's about how to screw over a customer or something else. But there's a lot of also other stuff that just you accumulate over time from a whole bunch of life lived and experiences had. And I think there's a lot of valuable stuff there that if we can, we should mine, right?
Yeah.
And make use of. So.
I mean,
I've kind of joked a little bit with some people about how over the next 5 or 10 years, we're going to need to develop a middleman revocation program for all the people that are going to be disintermediated by the blockchain. So, sure, I mean, figure out somewhere where they can go and where they can put their knowledge and experience to good use. They're going to need it.
They're going to need Mark Finneran, can I ask you to comment on that a little? We had a conversation one time at the Collaborative Internet Meetup where Mark was actually the first person that I had heard who really dove into the conversation that was happening a lot over the last year or so of robots are going to take all of our jobs, right? And Mark had thought quite a bit about that.
Wow, talk about maybe on the spot. Yeah, thinking a lot about it. I think in general, I am a big fan of basic income, basic general income. I think, and we have to get to a model of redistribution of wealth and find a way so that you have your basic needs met, aka food, shelter, and health insurance. So that you have this basic income, and then if you are therefore not afraid anymore to lose your job or have to do 3-4 jobs to do that basic income, then everything else falls into place, in my opinion, because then the fear is gone and people are now can focus on what they really want to do and can create a much more joyful society. So that is a thought that I have at the moment, and we have to think about how can we make that a reality.
there's also something I call invisible architectures. We really risk, because we don't understand our systems. There's a lot of complex systems out there and how they interact. And a lot of the ways that exist we may just end up replicating those problems onto the blockchain. Okay? We may take, so as a for instance, Namecoin, you get to claim a name, okay? What we're doing is we're replicating a root. Yes, the root is decentralized, but there's still a root. The root, how you make a claim for that thing, but do you absolutely have to have a globally unique name? I don't know that that's absolutely required anymore. I think there are other ways to do things, and not understanding our invisible architectures means that we risk reproducing them, and let's understand them.
I've heard a lot of interesting conversation within the Bitcoin community about that concept, the basic income concept, and some related things. And again, the political theorist in me goes, yeah, I see the benefit there. And then I also go, well, how does that happen? And a lot of debate, I have like one real trick, and that is I look at how things work in small groups, because there's a set of tools that small groups have available to themselves that don't work at large scale. And that really has to do with the communication flow within a small group. So if you're in a little village and somebody gets sick or they are unable to work for a little while, the village takes care of them, right? But if they are a jerk or they're just being lazy, the village doesn't take care of them. Right? There are judgments that get made about what is acceptable and what is not acceptable, and those are fluid and they change over time. And the systems that I'm trying to work on have to do with enabling that kind of communication flow to happen at really big scale. I'm not opposed to the basic income type stuff. I think there could be something there, but I think that might end up looking more like which communities are willing to support you. Which communities do you have agreements with that think, yeah, he's part of us. We take care of our own. And I think an important sort of point there is that in small communities, transactions aren't the normal form of interaction. Right? We think about, I'm going to do this work for you and you're going to give me that thing, and it's about this trade. But when you're in a small community, that's not it. Do you tip your wife for making dinner? Do you under-tip her if dinner was cold? No, right? Because that wasn't a transaction, right? It was about a maintenance of a relationship. And the way that we perceive that is very different from a transaction. When we're investing in the relationship, we perceive that as a different thing. But that falls apart if you are unable to detect when somebody else doesn't invest as well. And at the large scales that we currently live at, there were probably 600 companies involved in the making of this thing, maybe more, right? There's no way for him to know whether one of those was using slaves or they polluted a river. So the communication flow, the scales we're operating at today, just isn't there in the way that it is in a small village. That's the stuff that I'm interested in. I think that Bitcoin and blockchain and these other decentralized technology may enable, but that doesn't end up being through a single consensus, yes, this is right and this is wrong, or I'm paying your... No, it ends up being, who are your people? Who do you support? Who do you want to interact with? Who wants to interact with you?
To plug OK Turtles again, you might be interested in their group currency project.
We got to chat, but then, yeah.
Okay.
There was a question in the back.
So actually I'm just here to ask a question that a friend of mine wanted me to ask, and he couldn't make it. He's in Las Vegas, got shot in the back, etc. He said that...
What?
Yeah. So he said that primarily a full blockchain, RevokeSSL, would work out to be the world's largest incremental certificate revocation list. And Mozilla recently dropped support for those. Do you guys think anything similar might happen with other browsers, or with a removal from HTTP 2.0 or something like that?
So yes, Mozilla's dropped support for CRLs. Interestingly though, Microsoft has dropped support of reporting errors with OCSP because they had so many failures that people were complaining about the
always getting
the warning because the OCSP was,
and
they
for those
removed
of
the
you
warning.
listening from the home audience, CRL and OCSP are basically your two methods of communicating a revocation. So one of the major browsers says, on one of them, and one of the other major browsers doesn't happen to notify you if it failed, if you didn't get a response.
So, it's a broken system. Do I feel like we want to put every certificate on the blockchain like what we're doing as a long-term solution? No. I think there's a whole it's hack. There's a whole bunch of people who need to solve this problem of a decentralized distributed hash table so that we can basically put multiple things on there. And there are a couple of companies that are building entire product lines around that idea. There's the One Name folks have one. Is that blockchain? Anyhow,
Have you seen Keybase?
Yeah, that's another one. There's a number of people who are trying to do some things in this territory.
And they're good things.
And they're all good things, and we'd love to support that. And then that way there's only one transaction every 10 minutes that's on the blockchain. And you get the DHT if you want to inspect the table. So.
The other thing is that self-signed certificates are basically going to be all but mandatory. There's going to be an HTTPS by default push instead of just opportunistically. Do you really think that people are going to be able to handle that?
This is why we need to start solving some of these problems now. The core thing here is we're splitting certification from revocation. Right now, they are firmly in hand and it's not working, okay? We're just saying, let's split them up. Here's an example of splitting them up. Let's find more ways and more effective ways, more efficient ways to do things that aren't centralized. I mean, there is an effort from Google called certificate transparency, which is kind of interesting. But it's like yet another are you valid type thing, and it could be that there might only be 2 companies, maybe 3 companies in the world who can actually deploy it: Google, Amazon, and Apple, which is a form of centralization also. So this is a hack.
And this would not eradicate the third-party identity attestation function of CAs entirely, I presume? You'd
Correct.
still be able to add that in, okay.
Oh yeah, it adds to, not replaces.
And have you found any proposals for alternatives to certificate chains as a means of the establishment of ownership that look promising or interesting? Whole new invisible architectures that you take?
Well, I mean, I'm enamored of cryptographic linked local names. That's my particular thing. But you can think of it in some ways as being another way of doing a web of trust. It's not PGP, but it's a logical thing from there.
Okay.
I think we can.
Other questions?
Yeah.
Matt, Christopher, that was great.
Thank you very much.